Hello everyone, in this theory seeker tutorial number 45, we will explain how the photovoltaic effect works in a p-n junction space charge, and we will remain that it is an invention of Russell Ohl working in the AT&T Bell Labs solid-state team. After finding that impurities were playing a key role in the semiconductor, Russell found that purity crystal was a starting point to be able to dope with different elements called P and N. Then, during experiment on p-n junction, he discovered that when light striking the p-n junction, electron flows from N to P side. I represented the conduction and valence band for an intrinsic silicon with 0 per electron hole. If a photon has an energy higher than 1.2 electron volt, the photon energy will be transferred to the electron. The electron will jump in the conduction band with more energy, leaving a lack of electron or hole in the valence band. The electron with higher energy in the conduction band cannot stay there if no more photon. If no more photon energy, the electron will go back in the low energy position in the valence band, sending back a photon. This example is with an intrinsic silicon, but it will be the same in a P or N doped silicon. The photon creates a pair electron hole, and the cancellation of the electron hole pair creates a photon. I did again an analogy by replacing the electron by a person sitting on a chair, which means low energy. Then he stands up and gets higher energy with an elevator. If the elevator is removed, he will come back at the low energy position. On the right, I represented a p-n junction with its space charge and the diode symbol. The p-n junction and the diode are shorted. In a p-n junction, the space charge is equivalent to an intrinsic silicon with no free charges. But the only main difference is the electric field E provided by the space charge. So now, if a photon creates an electron-hole pair in the space charge, this electron will be immediately subjected to the electric field E, creating the force F equal QE. This electron, before it gets a chance to be recombined with the hole, will be subjected to the electric force and be sent to the N side. An electron from the P side will go in the space charge hole, creating another hole in the P side. The electron on the N side will get out through the external electrical circuit and will come back at the low energy position provided by the lack of electron or hole in the P side. The current is noted positive when the diode is biased indirect, as shown in the red rectangle. But with the photovoltaic effect, the photon creates current getting out from the P side of the diode, which means a negative current compared to the positive convention. Each photon generates one electron. As photons are coming as a flux one after one, so the generator is equivalent to a current source, so the generator can be shorted. Of course, if we replace the short by a resistor R, the circuit will provide a voltage VR across the resistance. If we continue to increase this resistance value up to the infinite value equal to an open switch, the current will become zero and the voltage across the diode will be clamped at the diode voltage close to 0.6 volt at room temperature. The dotted line represents the current in a diode biased indirect. When the diode is illuminated, the dotted line is shifted down, providing a voltage and a negative current. This is the photovoltaic effect discovered by Russell Ohl. As in the name photovoltaic we have Volta, it makes sense to compare the photovoltaic effect with a battery. I took a battery with zinc and copper electrodes. The battery operation is like this. The zinc electrode releases an ion Zn2+ and 2 electrons. This couple of electrons goes in the electrical circuit and get the copper electrode. Then those 2 electrons transform the ion copper 2+ in copper. Now we can compare battery and photovoltaic effect. The zinc releases 2 electrons while the photon releases 1 electron. Both electrons join the ion copper 2+ while the electron joins the whole positive charge. As we already said, because of the photon flux is coming one after one, the current is controlled by the photon flux, so the model is a current source. In opposite, the battery is a voltage source because all ions are already there in the electrolyte and they are available at the same time to provide a huge current in case of short. Here is an example of the photovoltaic application discovered in 1940. Just between Arcachon and Bordeaux, you can see in the yellow rectangle one of the largest photovoltaic power plants in Europe. If we zoom, we can see an area of 260 hectares with more than 1 million unit cells connected to a 225 kV network and able to produce 300 megawatt peak. The solar cells are oriented east-west with an angle of 5 degrees. The idea was to do not lose area because if the orientation were to the south, we need space due to the shadow between cell panels. The 20 kV inverters are transformed in 225 kV with 3 phases. The high voltage lines are buried to join the high voltage line few kilometers away. A specific equipment built for this purpose allows to clean the solar cell panel once a year. It is not sure that Russell could imagine this type of power plant when in 1940 he discovered the photovoltaic effect. I want to thank you for your attention. On my next theory seeker tutorial number 46, we will talk about the point contact transistor invention in the Bell Labs of AT&T in 1947. This invention was the starting point of the electronic business we know today. Those 3 inventors received the Nobel Prize in 1956. So see you soon and stay tuned.